Hello, hello, hello. Hi, guys. Good morning. Take popcorn, relax, sit back, and enjoy. The video right here is gonna be a movie because the production time for this video itself is actually very large. To make the notes of this video, it took 8 hours, nearly roughly, like going, coming back, and like this. But yeah, it's gonna be a long video for sure because I'll go on and give you every example for all the cases. If you have not watched the part 1, you can go and watch the part 1. It's the very easy way or the easiest way. Again, the part 1 is not at all linked with the current part 2 for the video or for the problem, because the part 1 problem says count the number of houses at a certain distance 2, and the part 1 was just a count of certain distance 1, and we used more or less brute force approach, which is Floyd Warshall, not brute force, but yeah, but the approach right here will not work at all. Let's see, have a quick recap what the problem says. The problem says, again, sit back and relax. But you saw one flaw. I looked at the company tax. This is a problem in the last contest, 1 week. And the company tax says that it has been asked in Oracle in 1 to 2 years, which means lead code company tax are also not reliable. What I feel. But yeah, let's see. The problem says that you are given 3 positive integers n, x, and y. Now, in a city there exist houses numbered from 1 to n which are connected by n streets. So you will see, okay, I have houses numbered from 1 to n. My n was 3, so I have houses 1, 2, and 3 numbered from 1 to n. One more thing, if the houses number would have been 0 index now, the problem would have been less, whatsoever. So, but yeah, it is number from 1, 2, 3, so it is very painful to convert that to a 0 index because the answer is a 0 indexed. But cool, no worries. Let's come back. There's a street connecting the houses number from I to the I plus 1. So, okay, you saw that we have 3 houses, and for every house I have a connecting street. I to I plus 1, I to I plus 1. Okay, that is one street which they are connecting. That, okay, for all the houses from I is from 1 to n minus 1. That is okay. For all the houses from 1 to n, I have a street connecting consecutive houses. And also I have one additional street from x to y. You will see I am given x to y, which is saying x to y, there is an additional street. Now you just have to figure out for each k, you have to find the number of pairs of houses so that the minimum number of streets. And now for the simplicity, let's imagine one street as one distance. So I have to give me all pairs for a street, for a number of streets that need to travel for each houses. So let's imagine one street as one distance, right? Now I am asking you, give me all the possible pairs for this saying distance of 1, distance of 2, distance of 3. So distance of 1, we have 1 to 2 as a 1 pair, 2 to 1 as a 1 pair, 2 to 3 as 1 pair, 3 to 2 as 1 pair, 1 to 3 as 1 pair, and 3 to 1 as a 1 pair. So we have 6 pair for distance as 1. Now let's take the next example to just figure out the distance of 2. Let's say here's again, we will consider one street as one distance to go from, because see, we just wanted the number of streets, right? So let's imagine one street has one distance. Now if I ask you the distance of 3, how many such houses are there? So you will say that, Aryan, I can see 1, 2, 3. This is the distance of 3 I can have. That is okay, but can't you just go and do the shortest distance, which means 1, 2, and 3, which means to reach here I don't need a distance of 1, 2, and 3. Nah, that is not the best or the minimum possible distance. Minimum distance is 1, 2. 2 is the minimum possible distance. So to reach here, 3 is not the minimum possible distance. Now if I ask you to reach here, the minimum possible distance is, one way is, okay, 1, 2, 3, 4. One way is this. But I'll say rather take this specific street and reach in distance 3, which means 1, 2, and 3. So to reach here, the distance is 3. So 1 to 5 is one pair having a distance 3, and 5 to 1 is other pair having distance. So basically we have to count both the pairs. As you can see, I have to count house 1, house 2 is one pair, house 2, house 1 is other pair. So I can, or maybe I can do is I can find the answer and then I can multiply in the end, multiply by 2. So we'll see for distance of 3. Again, I want the minimum distance. So that's the reason. I want a minimum distance. That's the reason in problem 1 we use Floyd washer, because we want minimum distance between all pairs of nodes. But you know Floyd washer takes n cube time, which we for sure could not perform because of the constraints right here, which is n is 1e5. Now, this approach which I have taken, for sure, I did not come up with it. Neither I see the explanation which I come up with it. What was very complex, but yeah, that also I later on came up. This guy Harsh Barodia, he has again. There were many other solutions which were actually short burning points by someone, I forgot the name, but yeah. This is the most intuitive solution which this guy gave. That's the reason I am picking up his solution. And again, shout out to him for amazing solution. But yeah, the solution itself needed quite a lot of explanation in that also, with a lot of diagrams. That's the reason the video is right here to represent every possible case with a diagram. Now, let's take a normal case. Which means you have some houses, then you have some other houses with a street connecting them, and then some more houses. That's a normal general case. Now I will break this entire case down. Again, remember, I want the pairs. So I'll break the problem down to a specific portions that I can find the answers for them. So I will break the problem. Okay, let's imagine this. See, now imagine the problem is, okay, you have some straight line, then you will have some cycle, then you will have some straight line. Earlier, if I would not be having any of the new house added, so I will have only a straight line. We will see that. But in this case, I was having a cycle. You remembered, right? If you join to x comma y, then you will form a cycle right here. So okay, I can just bifurcate this entire problem into 3 portions. That one is my left straight line, one is my cycle, and one is my right straight line. Now Aryan, why we bifurcated? Because we know that we can have multiple options. Remember, we wanted house 1 and house 2, and all the nodes represent here are representing houses. So I wanted house 1 and house 2. I want a pair. And that pair, for that distance, I need to add in my answer. That is what I wanted. So I can have multiple possible options. One possible option is I can take both the houses from this left line. Let's name it as a left group or left line group. So I'll take this from the left line. Both the houses, house 1 and house 2. Other possible option is I take both the houses from this circle or basically cycle. Next possible option is I take both the houses from my right line. Other possible option is I take my house from left line to right line. Other possible option is I take my houses from left line to right, like left line to circle. Other possible option is I take my houses from circle to my right line. These are kind of the 6 possible options which you can have. But you will say, Aryan, are you mad? You did not count it right line to left line. You did not count it right line to left circle. That is true. Because I did not count it, because I know that when I will be finding my answer from circle to my right line, so it is for sure obvious I should not go and find my answer from right line to circle. Why? I can simply, whatsoever answer I have got so far, I can simply multiply that by 2 and I will simply get my answer. But okay, Aryan, that seems okay for the cases for the cases where you are going in from the circle to your right line and circle, and you're from left line to the circle and from your left line to the right line. For all these cases, it seems okay that you are multiplying by 2, which are the 3 cases. But in the beginning, you also told that okay, you will have a houses 1 and houses 2 in the same. Now in this same, you will still multiply by 2. Are you saying that? Yeah, I am saying that. Why I am saying that is because while iterating and while making a group in this left line itself, I'll make sure I'm making the group from left to right only. From left to right only. From left right only. I will not make the group. Let's say I make this group H1 to H2. I will not make the group like this. Inside this left line, inside this left line group also I will make the pairs from left to right, because I know ultimately I have to multiply by 2, because I don't want to count that again and again. So that is one thing. Okay, we got to know that we will have 6 cases. One case is all pairs in the left to your cycle, all pairs in the cycle to your right, all pairs in your left to right, and other 3 ones were all pairs in the left, all pairs in the cycle, and all pairs in the right. And thus we had to bifurcate in these group left, this is a group cycle, and this is a group right. So we saw that we bifurcated the entire representation in 3 forms: group left, group cycle, group right, and possible pairs will be nothing but 6. Okay, these are all the possible pairs which will be formed for us. So these are all the possible pairs, and again I told you that I will have something like house 1 and house 2 which I am planning to do, and ultimately house 2 to house 1 will also be a same pair, so I can simply multiply by 2 in the super end to actually incorporate this also. So make sure you're only going in from, while making a pair, you will go in from left to right only. You will not come back. Your arrow will never be like this. Your arrow will always be like this, make sure. Okay, great. Now let's come back and split the problems. But before splitting, are you sure that your answer will be just by these 3 possible cases? Which means, okay, you had your one problem, you bifurcated into 3 sub problems, you bifurcated, but then you figured out to actually find the answer individually you cannot find. You also have to pair these problems up, and then you know, okay, you will have 6 problems. But have you considered all the cases? You will see, again, that is not required, but you will see in the future that this cycle length, as you can see, again, if you just zoom a bit, you will see that I have numbered all the nodes also. That's the reason it took a bit time. Cool. That is the reason. We can see easily that, okay, 5, 6, 7, 8, and 9. Okay, 1, 2, 3, 4, and 5. So cycle length is odd here. Now I can say the same thing again: 1, 2, 3, 4, 5, and 6. Cycle length is even here. Now that can be useful, but again, that is no point for you to actually figure out. Again, now this all stuff which you see right here is actually by this Harsh guy, from which I actually took the reference to make these specific notes. But coming on back, we figured out that we have to bifurcate it into left group, circle, and right group. Now for that also we just need to figure out some specific answers. But before going on to the answers, if I ask you that what if you never had a cycle, which means you never had a connectivity, which means you never had this connectivity, then what you could have done? How would you have given me the answers? So if you had these houses, house 1, house 2, house 3, house 4, house 5, and house 6, if you had all these houses, it's very obvious that what you could have done is that you want from house 1, again, I'm only going forward. Make sure I'm only going forward. I'm not coming back. From 2 to 1, I'm not coming back. From 1, I'm going to 3 to 4 to 5 and to 6. I'm going on like this. Okay. So I can see, okay, from 1, one of these path lengths can be of length 1, length 2, length 3, length 4, and length 5. So I figured out from 1, I can have the lengths as 1, 2, 3, 4, 5. Again, there is no cycle being formed. So for sure, the path will be just a straight path. And again, this is the shortest path from point 1 to the other points. And I'm concerned about the lengths only, because in my array as an answer, again, the cuss which I gave in the beginning is that the array is 0 indexed. Now this 0 indexed array will store the number of pairs having the length between them as 1. And that's a 0 indexed. So make sure that it is a 0 indexed, and this is storing for length 1. Okay, great. Now if I go on to my next element, again I'm going on only forward. Make sure, because I know ultimately in the end I'll multiply by 2, because it's a backward pair also. So for 2, I'm going to 3, 4, 5, and 6. And you will see 2 to 3 is length 1, 2 to 4 is length 2, 5 is length 3, 2 to 6 is length 4. So I have these all possible options for 2 to other values, and same way for 3 to other values, for 4 to other values, for 5 to other values. Now if I want, again, this is actually your answer. Now if I want to sum up, I want to know, okay, because ultimately in the answer I have to figure out for length 1, let's say for length 1, for length 2, let's say length 1, length 2, length 3, length 4, length 5, length 6. Again, remember our index is 0 array, but here I am saying length. Now for length 1, I will have this pair, this pair, this pair, this pair, this pair. Oh, I have 1, 2, 3, 4 and 5. So I know, okay, for length 1 I have 5 pairs. Same way for length 2 I have 4 pairs. For length 3, length 4, length 5 I have 1 pair. That is okay, but are we saying that for every node I'll go on to every node, and for every node I will have to figure out, okay, how many, because for this node I know the length can be from 1 to 5. I can see a pattern. For the next node it can be length from 1 to 4. For next node I can see, because see, as I'm going forward it is a 1, so it has many range possible up to 6. 2, oh, one element is gone, I can only go for remaining elements. Or 3, oh, again element is gone, so I can go on for remaining elements. So for sure I know that the possible large length are actually decreasing, and they're decreasing one by one, because actually I am actually also increasing. So one way is I can know Aryan, it is linearly, this is a linear thing, so I can easily know, okay, it is from 1 to 5. So one way is you figure out a pattern. Let's say for you figure out, okay, I know that I will be starting from 1. I can just figure out the maximum length. I know it's a continuous numbers 1, 2, 3. So I can just have a summation formula. Let's say n into n plus 1 by 2. I know because my n will be 5. I know my n will be 4. So I can go on to this element 1. I can say, let's say my n is 6 here. N is 6, but I know the last element, let's say name it as LE. Last element will be nothing but n minus my current element. Let's say name it as I. So I know my last element is n minus I. So one way is that I figure out a formula that, okay, because I know it's a straight line, so I will say my summation. But Aryan, are you kidding me? You don't want summation. You want the count. You want the count, which means you want, okay, how many times 1 came, how many times 1 came, how many times 2 came. Aryan, that's true. What I can do is I want the count of all the numbers, which means if this is my array, I need to add, okay, for 1 I need to add a 1 because I am standing at the node 1. I have to add a 1 here, 1 here, 1 here, 1 here, and 1 here, which means I have to add a 1 in a range. Oh, that's a range addition of a number. When we hear about range addition or range operations, the thing which comes in our mind is Fenwick tree, segment tree, or range sum queries, range modification. Then Fenwick tree can work and segment tree can work, but I don't have that much brain. But you will see that, okay, next time my range is at, okay, 1, 1, 1, 1. But if you remembered, I'm simply, okay, adding in a range is one operation with which we can learn back from our experience that we can use a Fenwick tree or segment tree. But is it useful? No. Why? Because segment tree and Fenwick tree are actually useful when you have queries also, which means if I do a range update, I should be doing a range query or basically a point query. But here I am never doing a query. Ultimately, in the end, I want to do one query in the end. When you have just one query, again, I am saying I have range updates, but I'm not having any queries in between. My query is only one time, and that's so in the end, I just want to know what's the final answer. So in these cases, we actually use prefix sums rather than range updates. And because see, Fenwick tree and segment tree are used when both range updates or point update. See, a Fenwick tree has 3 variations: range update, point query, range update, range query, and like point update, range query. So in these 3 cases, again, these should be done while like it might happen that I might ask you do a range update and then do a range query. But then if I'm asking you, you can do range updates parallel, like you can do range updates, keep on doing it. Ultimately, in the end, just let me know the answer. So what I can do is, instead of doing like this, if you remember prefix sums, it simply says that simply add here, simply add a +1, simply add a +1 here and -1 after that number, which means 5 is there, so I'll add a -1 here. Again, remember that's a one index because I'm showing you for the lengths. What will happen with this is, again, what will happen with this current thing is, if I do a prefix sums, so he will add a 1, 1, 1, 1, 1, because see, all the values in the beginning are 0, like in the middle are 0. So I will keep on adding 1. As soon as I will do a prefix sum with a 1, with a minus 1, it will become a 0, and will keep on propagating the 0 values further. So you saw that if you populate this values as plus 1 and minus 1, then if you do a prefix sums, then you can actually populate this entire values in the between. But here I showed you for the stage, like one of these stages, which means when my I was at 1, let's say my I was at 2. I know if my I is at 2, I know that my possible range length is 1 to 4. So I'll add a plus 1 here and a minus 1 at 5, because I know that, okay, up till the length 4, I want the numbers. And the same way for 3, okay, plus I know the length can be from 1 to 3. So plus 1 for the minimum length and minus 1 for the maximum length. And the same way, plus 1, minus 1, plus 1, minus 1. And that's how, when ultimately this will actually become, again, if I just write this exact now, it will become 1, 2, 3, 4, 5. It will become a plus 5, minus 1, minus 1, minus 1, minus 1, and minus 1. Now, if I do a prefix sums, I will get a 5, 4, 3, 2, 1, and 0. And this actually is what we wanted in the answer. So this is the exact same thing I represented. So now you have got to know, if you had a straight line, but bhaiya, how is this useful? Will you use this? Yeah, I will use this, because if you remembered, I bifurcated my problem into 3 parts, which was, if you remembered, which was the left part, circle, and the right part. So for this left part, it's a straight line. For the right part, it's a straight line. It will for sure be a straight line. Why? Because circle, I know, it's just, it will be only one circle, because I know there is only one x and y which can connect. So I know it's just one circle. At max, it's one. Again, I'm saying at max, because it is highly possible that your x and y both are the same points. As in example 3, you will see, for example 3, I have not pasted here, but in example 3, you can see that x and y can be both same points also. So it can be something like this. If it is something like this, then for sure the entire thing is a straight line itself. So we can handle that in our circle case itself. But right now I can just saying that my circle will be nothing but x and y, that's one portion, but this left part and the right part will be a straight line. And for the straight line, I can, again, I showed you in the beginning, we have 6 cases, right? One in the left, one in the right, one in the circle, one in the left and the right, one in the left and the circle, and one in the circle and the right. There are 6 cases which we have. So for these 2 cases, which means left and right, only left and right, I know I can compute the answer using the strategy which we saw just now. No worries, we again see that a quick glance, but that is, we have got to know one part. Again, we are going from the very basic to next level. But for that, we know that we wanted to have a few things in mind, because if you remembered, we were concerned about the numbers. Let's say 1, 6. Okay, you have the numbers, but you actually, okay, you have named all the houses, and that's just a sequential numbering, but that's okay. So you also want the length of this 1, 2, 3, 4, 5, because you remembered when my length was a 5, because 6 minus 1 is 5. So I know, okay, I can go in from the length 1 is length 5. Then I saw, okay, 2, like 6 minus 2, length is 4. So I can go from length 1 to 4. So I'm concerned, okay, from the length itself, I can figure out how far I can go. So one thing is for sure, I just compute, okay, the length of the left part is nothing but, if I have my x at 5, so length of the left part is up till 4 only. I should not include this specific edge. Remember, okay, where is this gone? Where is this going? Yeah, remember, your length of the left part is this specific left part only. It should not include this specific edge, right? Make sure it should not include this edge. But Aryan, with this fact, how is it even possible that you are not including this edge? Like, will you not include this edge, or what are you planning to do? No worries, hold on. You might say that I am not including this edge. We will make sure that, but while again, but I can see the length of the left part is 1, 2, 3, 4. But okay, length of the left part is 1, 2, 3, 4. But when I am finding the answer for my left part, I'll only include this specific portion. When I'm finding the answer for my right part, I'll only include this specific portion. When I'm finding the answer for my cycle, I'll only include this specific portion. But when I am finding the answer from my left to my cycle, then I will start including this portion. When I'm trying to find the answer from my cycle to my right, then I'll start including this specific edge. So make sure this nitty-gritties of how edges are being used. So we will keep my left entirely separate, we will keep my right entirely separate. When my left and the circle and the right will actually merge, then only I will be using that specific edge. Okay, so now we have seen, okay, our actually left length in terms, in hypothetically saying, it is 1 2 3 4, which is this specific 4 length. Okay, I just removed that specific length, but yes, no worries, it is 4 length, but it's just a number for you to just make sure. ठीक है, 4 length दिख रही है, हाँ, that is visible. And same goes, okay, length is nothing but 3, as you can see, 1 2 and 3, but still it can highly change upon what we are actually about to do. Now coming on to our case 1, nothing but case 1 is as simple as that. We will simply operate on our straight line. So we know that we have bifurcated our straight line into these two portions. So if you just see, again, straight lines are both in the left and in the right. So I will just say to my main function that bro, firstly, and again, I will just make sure that my x is always less than my y, so that it's a uniformity maintained, that I will be going from x to y, or basically x is in the left portion of y. So I just compute these values, not required at all, this line is not required, and this is also just to make sure, okay, now you know the left length, because if it's a straight length of some specific length, then you can just simply keep on operating on the answer. But no worries, also just the thing which you have to make sure is the first answer. Again, you can see we have 6 cases, and 6 cases are exactly as we discussed, that we will have 6 cases. The first case is the left line. So again, for the left line, I said for the left line and for the right line, I will use the same function, because I know it's just a straight line. So to modularize the code, I use the same function, and the function simply, it will just be getting the length of this line. I'll give the length of this line. Again, remember, I'm giving the length here as 4, but he knows that he has to operate on this specific length. Remember that fact. Cool. Although you can also give according to you, but yeah, I'm just showing you that there are multiple ways to do that. And I can use the same function for the right line also, because that's also a straight line. So you will see I'm using the same function line answer for both left line and right line to actually compute and see. And always remember, these all these functions are actually populating our array itself, are populating our array itself. So you will see that I will say, you saw that, okay, these are populating the specific, how much contribution they will give. Again, no worries so far if you are not understanding. I'm just giving you a high level overview of, okay, what actually you can expect later on when you will go on to this function, what he will return and how that can be used in the answer. So whatsoever he will return, I will simply copy paste that specific index value in my answer. So it is just, you can imagine that they are individually contributing what, okay, for a specific length, let's say d, for specific length d, how many pairs what the straight line will contribute, how many pairs this end straight line will contribute, how many pairs my cycle will contribute. These are individually calculating that, and ultimately I'm adding that in my answer for all of them mentioned above. And then again, remember, because I'm going on from the left to right only, so I'm simply multiplying by 2. Now coming on back to our line answer, which means calculating the answer for the left line. So if we come back now, if you remembered that it's just one specific line, right? And we can just simply say one thing, okay, I know that I will only operate on this specific portion. I'll only operate on this specific portion. If I want to only operate on this portion, I know that what I have passed in is x minus 1, which is the length of 4. As you can see, length of 1, 2, 3 and 4. Length of 4 I have passed into him. And same way for the end portion, which is nothing but n minus y, which is 1, 2, 3, I have passed in a 3. So that is very obvious. I have passed in these specific values. But what is the answer? You will see that how many ones, again, you can visually see that how many ones we have. 1, 2 and 3. We have three three pairs of length 1. One pair is 1 to 2, one pair is 2 to 3, one pair is 3 to 4. So one thing is obviously sure, that we have three pairs of length 1. I know my length was 4, which I have passed in. I have passed in length of 4, but I know, okay, I will never consider the last specific length because that is from group to cycle. That specific edge from group to cycle. But if I only count for this specific, if I only count for the node itself, then it is only three edges I have. And for sure you can see just 1 length for a length of, sorry, 1 for a length of 1, 2 from 1 to 3, and 2 to 4 is for a length of is for a length of 2, and for length of 3 is just a 1. So you can easily see it's a linear thing. Okay, one pair contribution is 3, 2 pair contribution is 2, 3 pair contribution is 1, 3 length contribution is 1, and the same way you can see line length I have passed in 3, but I know that I will simply be operating on a length of 2. So for a 1 pair, answer is 2. For a 2 pair, answer is, for a length of 2, as in for a length of 2, answer is we have just one pair. This is a very slow, but cool, no worries. So you saw one thing, it's just a linear thing. Although you can here also do a prefix sum as we saw above, but then we realized that this is the length and this is the length and this is the number of pairs. This is the length, this is the number of pairs, and it is simply linear. So I can simply linearly write down the same thing. So I can initialize my addition with line length -1, because you remembered line length was 4, but I am contributing like for a pair of length of 1, I have 3 pairs, which means 4 minus 1, and it is a linear. After that, it is a linearly decreasing, as you saw 3, and then it is linearly decreasing. So I can simply say addition initially, this value will be nothing but line -1, so it will be nothing but initially 3. So for a length, again I am saying for length of 1, but you remembered our array are 0 indexed. So for a length of this thing is saying the contribution of answer for length of 1, but the answer I have to store in at the index 0. So it's the reason I did a -1. So for a length of 1, I will add a 3. For length of 1, I'll add a 3. Next time what will happen is length will keep on increasing, because you saw my length will keep on decreasing, 1, 2, 3, but my addition value, it kept on decreasing. Because I know that is simple visual representation pattern which is being formed. Again, it's a pattern which we can see in a linear length. So I can simply say I can simply keep on decreasing my addition value, and I can simply keep on increasing my length value, and that also I can keep on adding. Now with this function itself, I will be able to find the answer for my straight line. Now straight line part is done. So with this help, what we have achieved is we have achieved the, again, this is added in a vector called as line answer, line 1 answer, and the same function I can call for a line 2 that will add line 2 answer, like in a vector. So it's a vector in which I'm simply adding the values. Okay, my left line and right line are done. And for that individually, for a length, for a specific length, I have added how many pairs they will contribute, like he will contribute and he will contribute. How many pairs both of them will contribute in their different vectors, line answer 1 and line answer 2, because I know that ultimately in the end I will simply add that in my result for every of the corresponding length values. Here I is from, again, that is an indexing based. So I0 means length of 1. Length of 1, how many pairs my line 1 answer contributed. This I can simply keep on adding. Now I'll not repeat this in the again. So yeah, now I'll go on to my cycle. If I have to go and find the answer for my cycle, let's see how a cycle will look like. And the cycle is the only most trickiest part of this entire program, because it will have so many number of cases. Because you can see, if I just make a small down, so you can see this is the cycle explanation. So you can see that cycle will have cases. How and what? Let's see. So one thing we have got to know, that we have to now inside, we are only inside the cycle. So what we can say is, okay, that is great, we are now inside the cycle, but cycle can have odd length or even length. But Aryan, one thing, how in the world we would know that we have to think about odd and even? For a line length, you never spoke about odd and even. But then for cycle, you are saying odd and even. Why? But you know the answer, so you're saying, but how would we know? Okay, great. You would not know. Let's see. Let's build the example. So let's take an example that we had a simple array, an x and y, and I'm only concerned about this specific portion. Make sure I'll not go outside this portion. I'm only concerned about this specific portion. Forget this entire part. Forget this entire part. Now, this is the point x, this is the point y, which was the question given. If I ask you, take any random point, take the point 5. Now you have to find the shortest distance with 5 to all the other values. So I can say at a distance of 1 I have 6, but at a distance of 1 I have a 9 also. At a distance of 2 I have a 7, but at a distance of 1 2 I have a 8. Oh, but okay, then you can see for a specific node 5, I know that I had 1 2 3 4 5. My length of the cycle was of 5, so I know in any of the cases I am going in, okay, 1 here, so 1 from here, 2 here, 2 from here, 3 here, 3 from here. So for sure I'm always going same values, and I will for sure meet in the middle, because you can see the number of elements, it was 5 6 7 8 9. I had 5 elements, which means odd number of elements, and you can see 1 is occurring in pair, 2 is occurring in pair, and for sure from the node 5 itself you started. So this is something but 2 into some pair values, and I was saying starting from the very beginning, which is odd. So you can see that for sure these value will always occur in pair, which means for odd length cycle, if you're starting from the node, so number of pairs which he can form is in even. You can see 1 1 2 2, and you can also build the bigger example. Let's say here I took only 5 nodes in the cycle. You can also take 7 nodes, 9 nodes, so as to make sure that you know one thing, okay, I will have 1, then 2, and then 3, like this. So I will always have numbers in pairs. But is it important? No. So what if I had one more node, let's say a node 11 here, so he would be reaching here in distance of 3, and from back also he would be reaching here in distance of 3. So from node 5 to node 11 I have only one distance value, which means for distance value of 3 I have only one pair, 5 to 11, and no matter what, you can go from here or here, it's just one pair. 5 to 11 is just one pair, that's it. So one thing, oh, which means if I have an even length cycle, so I can go 1 from here, 1 from here, 2 from here, 2 from here, 3 from here. Oh, that is the reason. That's the reason how you came up to a point that it can actually differ if you have an odd length cycle or an even length cycle. Now we have got to know, okay, we will have two cases. We will have to figure out two cases, one for the odd length cycle and one for the even length cycle. So right now let's see for the odd length cycle that how I can actually contribute. Now with this specific example, with this example which we have seen so far, we had seen, okay, when we started from the node 5 taking as one node, I could see length 1 contributed how many times? 2 times. Length 2 contributed again 2 times. Okay, that is great. But the point here to consider is I only had a maximum length of 5 by 2, because I know both my length is, let's say my length 1 2 3 4 5, my length of the cycle was a 5. I know, okay, 1 I'm going here, 2 I'm going here, so I know both sides I'm going in. So for sure if you have a rod and from both sides you will keep on going in the middle you will reach, right? In the middle you will reach. So I know that for sure I will reach in the middle, which means the maximum distance I can have is up till the middle of this cycle. Now middle of the cycle is 5 is the length and the middle will be 2 by 2. So the maximum I can reach to this cycle is 5 by 2, which is nothing but 1 and 2. And the same way for my even length cycle, I can reach in the middle, which is 6 by 2. So the maximum distance I can reach in a cycle from any point whatsoever to any other point is 1 2 and 3. That's it. Now Now let's see, again we have got to know that this is a possible distance for a cycle. Okay, I can have a distance of 1, I can have a distance of 2, but my question says that I have to find the count of all such distances. I have to count. My mom is calling, I don't know why. But my count, I wanted the count of all these values. Again, what will be the count? For that you have to again build the examples. So again, I know I will have 5. Remember, it was an odd length. Again, I'm just going on to the odd length. And odd length, I know I have 5 nodes. So for sure, every node will have every other values. So I will simply say, so for this specific node, I can have 2 of 1, I can have 2 of 1. For this node, I can have 2 of 2, I can have 2 of 2. Again, 2 will come from back. Okay, that is great. That is super great. And for 1, I have a 1, I can have a 1. Aryan, one thing, you are going back. You said you will never go back. Hold on. I said that. Just hold on. I know I said that. So, okay, go back 1, and you will see a 2 distance and a distance of 2. And now I'm just taking every node as a base node, and from that node the distance to all the other nodes. From this node, distance is 1, distance is 1, distance is 2, distance is 2. From this node, distance is 1, distance is 1, distance is 2, distance is 2. And from this node, distance is 1, distance is 1, distance is 2, distance is 2. So you saw that you can make again, length was 5. So I had 5 nodes. Length was 5. I had 5 nodes. For all the nodes, for a length of 1, which means for a length of 1, this length of 1, I had 5 into 2 such values, because for every node 1 was contributed twice. For every node, I have 5 nodes. For every node, a distance of 1 was contributing twice. For all the 5 nodes, the distance of 2 was also contributed twice. But I did, okay, for every node, for every distance, I'm contributing that twice. But did you see that I was also counting again? So I was doing a double counting. So please make sure to divide that by 2, because you were actually doing a double counting here. Which means if I have a pair from here to here, then from here to here was also counted when I had in the middle, and the distance of 2 is same counted, because I know ultimately in the end I will count this. So please, you have got a figure, okay, for a distance of 1, if you had a length of 5, so for a distance of 1, you are contributing 5 into 2, because you see 5 is the number, 5 is these all the nodes, and for every node I have 1 twice. So I am okay, for one distance I am counting that twice. And the same way for distance of 2, I am again, nodes were 5, and again every node are contributing and giving 2 values. That is also I'm counting twice. But in that, if from this to this I'm counting, but I'm also counting this to this. So please divide by 2 also, which we will do when we actually solve it. So you will see that if I go back, so yeah, so rather than multiplying by 2, I said, okay, I will only for every of the distance. So I'm saying that for, and again, so you remember, right, I counted twice. So I will not count twice. Rather, I'll say for distance of 1, I will add only 5. For distance of 2, I'll only add only 5. And that is nothing but a cycle length. So for, again, if I come back, I said firstly for distance, I will have only possible distance from 1 and 2. So for 1 and 2 distances, I know that I will have to count how many number of pairs I had. So I figured out I have 5 into 2, which means number of nodes, and each node was giving me 2 pairs. But then I thought, oh, I found out, okay, I was actually repeating the pairs. Here, if I was doing from start to this specific 2 in the middle, then I was also doing from this start to back in 2. So I know, okay, I cannot repeat this specific thing, because I know ultimately I will multiply by 2. So in that I will repeat. So counting will actually multiplied. That I don't want. So what I did was, I divided this specific value by 2. So now my contribution for distance will become the cycle length only. So I did the same thing, that the contribution of my distance from 1 to the cycle length by 2 will become a simple L, which means your cycle length. So for all these distance value, you will simply add a L. Which means for length of 1, I will have 5 such pairs, which means L such pairs. For length of 2, I will have L. L is nothing but cycle length. I will have L such pairs, right? And for length equal to 3, let's say if I would have my D as, let's say, more. So I would have possible D as 3, let's say, also. So for that also, I would have my cycle length as, so if the contribution of the number of pairs will be nothing but cycle length. So you will see in the code itself, you will see that length is less than cycle by 2. Aryan, you were doing from length 1 to length equal to cycle by 2. What is less? Okay, I saw that you are actually doing cycle length, adding cycle length, which means for length 1, you are adding cycle length, which you already showed. Okay, for every length, I will simply, for every distance, this is a distance length, I am adding the cycle length as the specific number of pairs for him. So I am doing that, but you did not do it for cycle length equal to L by 2. Because for equal to value also, you should actually add, right? Yeah, add. That is true. That is completely true. So you will see if my cycle length is odd, I have simply added the cycle length for this specific L by 2 length. But Aryan, why was it needed to have it added in a different condition? Why you could not have added same in this line specific itself? Because for the even length, the things will change a bit. How they will change? If you remembered, for the even length, I had these 3 possible distances, 1, 2 and 3. Now let's try to find out how many such values, or basically how many for the distance of 1, 2, how many such pairs will be there. So if I just go and come back, I will firstly find the answer for distance 1 and 2. I will go and find the answer for distance 1 and 2, which is nothing but saying the distance which is less than 6 by 2. And this will be nothing but 6 by 2 value itself, which we saw also in the code, that although for the odd condition, you can simply go up till 1, 2. All will give you the same result. But in the even, I am saying, and you will see by the trirun, I give you the entire trirun also, but in the even, we are saying that the last length 3 will actually give us less values. But Aryan, okay, you are saying right now, so you said by building examples. Yeah, true. I am speaking this by building examples, and you also can only speak by building examples itself. But a quick glance I showed you in the beginning also. What I showed you, if you remembered, was if in this case, if I put a middle node, if I would have put a middle node in between, then you saw that from this star to this middle node and this star to this middle node, this is nothing but 1 pair only, which means 5 to 8. That is just 1 pair, 5 to 8. For length 3, I had only 1 pair, while for odd cases, for length of 1, I had 1 pair from this star to 1 and this star to 1 in the band from the back. So it's obvious that for the middle value, which means 6 by 2, for the even length, which is middle value, it will be less number of pairs, and roughly saying half number of pairs. So again, if you had known, so you can just simply do a half and you will be good to go. But for you, I will show you examples, proper try run. But if you had seen, then by intuition you can see it's actually half for your L by 2 length, and for the remaining it is nothing but L itself, because it will simply keep on repeating. But for you, I'll just show you that for a cycle length where it was actually less than L by 2, you will see that you will have these specific values. Where's my diagram gone? Straight line cycle. Okay, my diagram is gone. Cool, no worries. I'll show you that in this specific thing, how many number of cycles. Again, that's exactly same, that if for distance of 1, let's say if I take a star here, distance of 1 will be this, distance of 1 will be this, distance of 2 will be this, distance of 2 will be this, and then will be distance of 3. This will be a distance of 3, which I'm not counting. I'm only counting up till the L by 2, like this distance, and this I will keep on repeating for all the nodes. As simple as that. So right now I did for this one node, so every node will give me 2 values. So remember, every node is giving me two values for distance of 1 and 2, right? And if I'm asking you for distance of 1, how many such pairs will be there? I know for one node I was getting two values, so for n nodes I will again get n into two values, but I know that will be repeating, so I will divide by 2, so I'll get simply n, which means nothing by cycle length, or basically the number of nodes here, 1 2 3 4 5 6. That's it. Now the same thing which we can actually do here itself. For I'll just simply do up till, if I just erase this entire thing, up till cycle length by 2, I'm doing adding a cycle count. Okay, that is done. But what about if it is a middle? Simply, if it is a middle, you will simply see that you have this specific pair, this pair, this pair. Now for sure this is other pair, this is other pair, or you can also write the same thing as this pair also, but yeah, this is other pair and this is other pair. I'm only going forward, but this thing, this pair to this pair and this pair to this pair, it's actually repeating. So if I have n nodes and for 3, which means just a middle value, which is nothing but cycle length by 2, I have only one possible one pair. So you saw I made all the 6 pairs. I made, again, if I just show you thoda bit karke, I made all the 6 pairs, and thus I saw that okay, half of them will actually repeat because of the same pair, and that repeating thing I'll do in the end. So I just simply said I will do a L by 2 contribution. Again, the contribution of this distance of 3, distance of cycle length by 2, distance cycle length, the contribution of the number of pairs for this distance will be nothing but cycle length by 2 itself. So if I come back and show you, it will be nothing but that the contribution of cycle length by 2, length, the number of pairs will be cycle length by 2 only. That's it. And thus I can just find and figure out the cycle length for my, I can figure out the cycle length for my answer. That is again a part done. So we have done so far 3 parts. Now comes the part for straight line and cycle, which is the most trickiest part after cycle. Now again, for this I will say simply that now I have to take one node from this line and other node should for sure be from this cycle, right? Okay, and the same way when the cycle is being involved, so the odd and even length will also be involved. So one node from the line and other node from the cycle. I have to consider both the cases, odd length and even length. Now if I am saying that one node should be from the cycle, sorry, one node should be from the line, other node should be from the cycle. What all possible distances are possible is the first question to us. Remember, our node should start off from 4, right? Our node should start off from the 4. Now I cannot start from the 5 because 5, again, I am saying one node should be from the line. Line, you remembered, said this part. Cycle was saying this part. So one node should be from the line, one node from the cycle. So I am for sure saying my shortest possible distance to all the nodes in a cycle will be starting from the length of, from the node 4, from this specific node 4. And I can obviously see that okay, the distance can be okay, 1 2, the distance of length 2 here, and distance 1 2, distance of length 2 here. So minimum possible distance from my line to my cycle will be of length 2, but Aryan, hold on, you missed this 4 to 5. This is the length 1. Correct. I missed that because I will add that in the end. But right now, from the cycle points, from this pair, okay, no worries. This pair, I will handle that. No worries for that point. But right now, if I just ignore this x pair, which is just immediate to me, I can simply say that I will have a minimum distance of 2. Okay, great. Now, why in the first place you are figuring out the minimum distance? I want to figure out the minimum distance because that's I'm saying it's a minimum distance. So maximum, okay, but that's minimum distance for this specific node. But okay, length of 2 can be there. It can also go and increase. I can also say length of this and length of this as 3. That's also obvious. Oh, that's also obvious. That makes sense. But for this length, I can say, okay, length of 2 was there. I can also say length of, again, when I'm saying length of 2, I am saying, okay, for the specific index 1, I can have, which means length of 2, length of 3, length of 4, length of 5. But how in this first place you got all these possible lengths? No worries at the point. It's just that I'm saying, okay, this was 1, length of 2, length of 3, length of 4, length of 5. This is how all these nodes will contribute their minimum lengths in the answer. But Aryan, why you are teaching us the minimum length? What, how is it even useful? No worries. Let's see how is it actually useful. So firstly, we take the contribution of a house at maximum distance in the cycle. Let's see. Let's bifurcate that. Let's bifurcate that. Now for bifurcating itself, we will need to have, if I have my pictures, yeah, I destroyed my pictures, no worries. If I have these pictures, so you will see, I'll firstly tell you the contribution of the points in this line to that of the cycle. For this specific part, I will simply say that, oh, what is the contribution of my point? Okay, I erase this specific, yeah, contribution of this specific point, because it's a line point. This is a cycle point. I'm asking you, okay, I know one thing, that length of 2, again, forgetting the point x for now, because it is just attached point to me, so it's just, okay, attached. So attached, I'll handle it later. But for the other points, I'm saying that the distance of 2, which means the length of 2, and here the length of 2, how much contribution I could have. But Aryan, one thing, why I'm not counting the length of 3 here? Because length of 3 I will count in the same way I counted the maximum distance length. If you remembered, while we were counting the cycle answer, we bifurcated. The maximum distance point we will handle separately, and we will handle other points, which are the lesser points, we will handle separately. Right? We saw that because of the cycle length, the maximum, again, we remembered the maximum distance point will be nothing but L by 2, the cycle length by 2. For the only cycle, it is the case for only cycle. We saw it is L by 2. But then while we were figuring out the answer, we thought that, okay, for the odd length, I had the possible distance option is 1, 2. For the even length, I had the possible distance option is 1, 2, and 3. But this 3, which was the maximum distance for my even length, was actually giving us or behaving differently than all the other smaller values. So what I thought of was, okay, I will just, so as to make the uniformity and make a shorter code, I will handle the smaller, this is the maximum distance value, and this is the other values. So I will handle the other values same way for both odd and even. For odd, I will handle the other values same way how I handle this specific smaller values also. But for the even, I'll handle the maximum distance value a different way. Just saying a half way. Now, using the same concept, we thought and bifurcated that, okay, maximum distance value I will handle separately for both odd and even, but the remaining distance value, which means the lesser values, I will handle. Again, the maximum distance I'm saying for any specific point to their farthest point which I could have. So I can easily see that for a length of 2, I will have two possible pairs. Okay, for a length of 3, again, for a length of 3, I want a point from my line and a point from my cycle. I will have, again, 2 possible pairs, which are the green lines. Length of 3, I will have 2 possible pairs again. Okay, for a length of 4, again, I will have 2 possible pairs. Okay, again, 2 possible pairs. And for a length of 5, I will again have 2 possible pairs. Now, you might end up saying that, okay, Aryan, with this fact, it seems like that I will have my answer. So let's name, okay, my answer is 0, 1, 2, 3, 4. So this is my answer. So you are saying that for length of 2, again, when I say index 1, it is a length of 2. So you are saying that length of 2, I will simply add a 2. For a length of 3, I should simply add a 2. For length of 4, I should simply add 2. Are you saying this? Technically yes or technically no. Because right now you just have a small picture, which means here the cycle, here the, see here the smaller length was just one length, which is length of 2. The maximum length is length of 3, which is the high length, which I said I will handle separately. Ultimately what I wanted to say was length, let's imagine the cycle length would have been other things very high. So my smaller length would have been 2, 3, 4, 5, and the higher length would have been 6. Let's imagine this. Right now, currently in this example, my smaller length is 2 and the higher length is 3. This is all the possible length for a specific point 4. For specific point 4, I have these possible lengths, distances. So I am saying I'll handle the maximum length differently, and I'll handle the minimum length. I'll handle the minimum length like together. So this would have been handled differently. Length 6 would have been handled differently, but for length 2 to 5, 2, 3, 4, 5, you will have to handle it together. So are you saying that when you are handling the length of 2, you will only add a 2 for length of 2? You will only add a 2 for length of 3? Just for a length of 2 only, you are adding this. Will it continue? No. Here the prefix sum will come in picture. You will not understand until unless I'll give you an example, and I'll give you an example by the even length. So right now, just shush and listen until the even length is finished. In the even length, you will understand. You will see that I am actually doing something of the prefix sort, which I did previously when I was showing you linear. This thing I'm doing. But you will not understand this until unless I'll show you an example by taking the even length cycle, because in that even length you will see that you will have a minimum distance of 2 and a 3, because the maximum distance is a 4. So maximum distance 4 I will handle separately, but this 2 and 3 I will have to handle it simultaneously, and to handle it simultaneously I will actually be using my prefix sum formula. But that will only be visible when I will actually handle my even length case, because in that the example is big. The example itself will have smaller values which are actually more, because in this the smaller values, in this the smaller values only just one value of length 2. So it was not much clear for odd length, but still I wanted to show you. But okay, right now if we hold on and see, so far we have seen for an odd length cycle, for the contribution of an element in the line to the cycle pair, we have seen that we can have a length of 2, length of 3, length of 4, and length of 5, and we saw that all these lengths contributed 1 1 as an answer. And if I write the same thing, okay, for length of 2, length of 3, length of 4, and length of 5, if I write the same thing, as you will see, I wrote it down. Okay, this is the length of 2, length of 3, length of 4, length of 5. I wrote the same thing down as a prefix sum formula. Again, no worries, just forget that. But yeah, just make sure if you just do a prefix sums, then it will become a 2 0. It will become a 2 0. So you are saying that okay, you are only adding a 2 2, as you saw above also that okay, you will only add a 2 2 for every of the specific lengths. Again, remember one thing, that maximum length is still remaining for my odd length, but now I am coming on to my even length. For my even length, I know that I will again have a length of 2, length of 3, length of 4, length of 5. So let's look at the even length cycles. Now, for my specific, again, I am just starting off with one point for this specific point. So for okay, where is this gone? Oh shit, I just hate this entire structure. Okay, now I am right now at the even length cycle. So for the even length cycle, for this specific point, you will see that he will contribute the length of 2 twice. He will contribute length of 2 twice. Again, you can see it's the same way. Earlier also, when I was doing only cycle, a point to a smaller distance was contributing twice and all that stuff. Same way is kind of more or less going on here, but it is right now the only thing changes from a line to a cycle. Again, for the specific point 4 only, he will contribute for a length of 3 again twice. Okay, now if I take the length, a point as 3, he will contribute the length of 3. Again, Rn, why not length of 2? Because I want from my line to a cycle, I want a point from a line to a cycle, and the shortest point will actually be nothing but this length of 3. don't argue with me why not a length of 2 right here, because you will see I will handle this case ultimately in the end. But Aryan, why are you handling it ultimately in the end? Because I want uniformity. I want uniformity. What I mean by uniformity is, if I say length of 2, number of pairs are 1, length of 3, numbers of pair are 2. As you can see, one is this and one is this. So I just want a uniformity. Okay, I'll only handle the two count once. Ultimately, one count I can handle that in the end also. So it's just about handling. You can also handle in the if case, depends upon how you want to handle. But yeah, right now just be with me. I will verify every case in the end also. So again, there's a problem which involves cases. I know that's pretty tricky. So for this specific point, to the point in the cycle, I know it's a length of 3, 1, 2 and 3, 1, 2 and 3 right here. Again, for you to zoom, if you want, you can like have it visible. And for this, a length of 3 will be here. Okay, but for this specific point, I can also have a length of 4, length of 4 and length of 4. And let's say for this specific point, I'll go length of 5, length of 4, length of 4, and this first one, length of 5, length of 5. For the last point, this length of 5, length of 5, and for this point, length of 6, length of 6. So one thing, one normal thing, as I showed you, I tried for all the possible points on the line. It is the 0.4, 0.3, 0.2 and 0.1. I tried for all the possible points in my line. For 0.4, he gave me a length of 2, length of 3 twice. Okay, length of 2, he gave me 2 pairs. Length of 3, he gave me 2 pairs. Length of 3, he gave me 2 pairs. Length of 3, length of 3, he gave me 2 pairs. Length of 4, he gave me 2 pairs. So you saw length of 2, okay, it's occurring twice, but length of 3 count is nothing but a 2. Length of 4 count is 2. Length of 5 count is 2. And length of 6 count is 1. That is where my prefix sum will come in picture. How? Let's see. Now, if I come back, I will simply say length of 2. I know that for that specific point 4, I know that specific point 4, which was this specific point 4. If you remember, let's erase this dirty diagram. Dirty diagram. For this specific point 4, I knew he contributed for a length of 2 and a length of 3. And for sure, if the cycle length would have been bigger, then he would have contributed length of 4 also, and so on and so forth. But it's just to showcase that he contributed this one point contributed length of 2, length of 3. So I'll say that for the first point, he contributed length of 2 and length of 3. But remember, I cannot simply keep on adding plus 2 in the entire range. I cannot keep on adding plus 2 for length of 2, 3, 4 and so on and so forth. I can just say I'll simply add a plus 2. Why plus 2 again? Because I can see that one point give me 2 possible ways. One point give me 2 pairs from here to here, and also make sure they will never repeat, because the pair is always from my line to a cycle, from my line, and line is always on the left part. So this will also not have the same repeating statement like what we saw in cycle. So one thing is, my line, my length of 2 gave me 2 for one point. Length of 2 gave me 2 values. Length of 3 gave me again 2 values. So I know I have to contribute 2 in a range. If I say length as 2, length, again I'm saying length, whenever I say length, I'll write length. And here's length of 2, length of 3. I have to add this 2 in the range. So I know if this adding needs to be done, so I'll add a 2 here and a minus 2 at a length of 4. Again, this length, I say 2, so index will be nothing but 1, index will be nothing but here is a index is 2, index is a 3 here. So now with this fact, what will happen? Okay, if I just erase this, so with this fact, what will happen? I have did a kind of a prefix sum. So you saw, if I go back above, I added a plus 2 and a minus 2 here, and the same way I did length of 3, length of 4. So okay, length of 3, length of 4. Okay, same. You will see length of 4, length of 5, and the same way I'll keep on doing length of 4, length of 5. Because see, length of 4 is this, length of 5 is this, so I have to do a minus 2 on the next index, and that's how I just generated these values. Again, in this itself I have to do a prefix sum. In this itself I have to do a prefix sum. So I'll do a prefix sum here itself to find the actual contribution, and that's the reason if you remember, now I'm coming back to my odd length. That's the reason. The same way will work for the odd length also for the smaller values. So I will have to do a plus 2 minus 2 like this, the same way. Again, the same function will work for the odd length smaller values also. But now coming on back to our higher values. So if I just show you the code itself for the smaller values, which means for my d is equals to 1 to d equal to line length by 2, I'll simply keep on adding the values. I'll simply keep on adding, but you will see Aryan, but here you are saying line length, which means you are adding for all the values. Hold on. Here I am saying for all the non-maximum distance points, I am adding their contribution. I'm adding their contribution for all the non-maximum distance point. And what the code looks like? The code looks like, you see, you know, the minimum distance will be 2, because you remember you start from the distance as 1. So you are saying the minimum length itself was a 2. You proved that. So minimum length is 2. Maximum length you can just figure out from this cycle itself, that how far it can go. So I can easily see my cycle length was 2. C by 2, 5 by 2 is 2. So I can know that, okay, maximum how much I can go, because why that is needed? It is needed because if my cycle length here is actually, I know that, so I would know from this point, I know the minimum distance was a 2, but the maximum distance also I should be knowing, so that I need to do a range prefix sum in that distance. So that's the reason I just got to know my maximum distance. Now, as simple, the indexing are 0 based. So for that mn minus 1, do a plus 2, and this do a minus 2. And again, although the actual mx value would have been mx plus 1, sorry, mx minus 1, but here you are doing minus 1 also, so that will be actually handled, because here this is the index, so it is reduced by 1 minus 1, but this mx here itself, this was actually a forward index, which means the actual index, the actual maximum value would have been d plus cycle length by 2 minus 1. So when I want to go to my higher index, this value, when I want to go this value, which is next index, to do a minus 1 value, so I should be doing a plus 1. So that will cancel, this will become this, and this will actually go to a normal index range. Again, you can actually see and check for the example by putting actual values, because I have given you both the odd and even lengths example. Coming on back to what we were seeing for the maximum distance points. So points at the maximum distance, what we will do different, which means what we will add for them. So coming on back for the odd length example, when your cycle is odd length, you can see that the 0.4 will have 3 as the maximum distance, 3 as the maximum, like again, length 3 as the maximum distance, and that will be counted twice. Same way for this, counted twice. Same way for length 5, counted twice. Length 6, counted twice. So you can just simply see one thing, for odd lengths, it's being counted twice. So you can see for length 3, length 4, length 5, length 6, you are simply adding twice. So I can simply say for length 3, length 4, length 5, length 6, indexing are 2, 3, 4, 5, I'll simply add a plus 2 in these range. So prefix sum says add a plus 2 here and a minus 2 here, and then when you will do prefix sum in the end, you'll actually solve it. But we only saw for the odd length cycle. What about the even length cycle? Even length cycle also says the same thing. It's just a quite modification, that you saw the length of 4, 1 2 3 4, 1 2 3 1 2 3 4. So length of 4 is the length, but you can see this 0.4 to this 0.8 is just one pair. The same way it repeated for cycle, so it's just one pair. For odd length, I was contributing for this length, I was contributing 2 pairs for odd length, but for even length, I'll just contribute 1 pair. That is the reason in my even length, for the maximum distance length, I will simply add a plus 1 rather than a plus 2. So if we go and look back at the code, you will see I will firstly find my minimum and the maximum distance to that, from the point to the maximum distance to the actual cycle. I'll find the minimum and the maximum. Now this this minimum says that for the very first point, okay, where is this gone? For the very first point to the maximum distance in the cycle to any of the points, what is the minimum distance? Now maximum distance says, okay, from this maximum distance, what, sorry, from this farthest node in the straight line, what is the maximum distance to the maximum distance point to the cycle? So I'll simply say this is the maximum distance. That's it. You will see that, okay, line length is actually added in that. When I have got this, I know one thing for sure, that for my even length cycle, I will add a 1, and for odd length cycle, I will add a 2. So I know I will have to do a simple, the same way. Plus of this specific addition is nothing but either a 1 or a 2, depending upon if it's an odd length cycle, I will add a 2 and subtract a 2. And if it's an even length, okay, sorry, I'll look into it. But yeah, for a people are calling because, okay, cool, I'll tell you later on. But yeah, and for the even length cycle, I will simply add a 1 and subtract a 1. Now you saw, okay, you just did, you added and subtracted value here, you added and subtracted value here for the maximum distance in the cycle and for the all the other non-maximum distance in the cycle. But still, you just placed some values, but you never did prefix sum, right? So now you will simply do a prefix sum to actually accommodate those values. So I will actually accommodate those values and will find the prefix sum. And now ultimately when this entire thing is done, so you might think entire thing is done, but no. If you remembered, I missed one thing in the very beginning. The one thing which I missed in the very beginning was the distance from this point to this, which means this specific edge. If you remembered, this specific edge was missed. So I'll simply say, okay, from point 4 to point 5, I will have length 1, length 2, length 3, and length 4. So I'll simply say that, simply same thing. So I will just simply say that for all the possible lengths, simply add a 1, 1, which means for length 1, I will, for length 1, contribution is 1, for length 2 contribution is 1, for length 3 contribution is 1, for length 4 contribution is 1. So for all the lengths, I added that specific length also. And thus my answer from my left to my cycle is done. And the same way I can repeat, and the same way if I go up, I can see my length from my length to my cycle, from my length to my cycle is actually done. And the same way it is the length, and this is the cycle, and this is the length again. So from this to cycle is done, and same way I can say that from this to my cycle I can also call the same function, exactly same. Okay, now that is also done. Last thing remains, which is from this line length to my this specific line length. This is simply remaining. Now this entire thing, this is the only thing remaining for us, from one of the extreme line length to the extreme other line length. Now if I go back, so if I show you that again, the one which I showed you for the cycle length, I just written here. But yeah, so it's just the contribution, okay, length 1, length 2, length 3, length 4, and so on and so forth. But now comes the last part, which means for the two straight lines, what is the contribution? Again, the exact same way, is just that we will now start using this specific. If I go and look down, if that, this is example. Now I know this is the left part, this is the right part. I know I have a cycle in between. Now I will start using my cycle as the minimum distance. That's it. So I know one thing for sure, that what is the minimum distance I have? Okay, this is the point I have to take from, this is the point I have to take from here. So minimum distance is, okay, point from here to a point from point to here. Now in between I have these values. So if I ask you the minimum distance from the extreme point on the left side and the extreme point and the first extreme point on the right side is nothing but 1, 2, and 3. So minimum distance is for sure 2 plus, but Aryan, you know the minimum, you know for sure, Aryan, the minimum distance is 3. Then why have you written 2 and then you have added a plus? Now that plus is what? Bro, if you remembered, my x and y can overlap. So if you are saying your x and y both are here, so which means your cycle is here. So for sure your left portion would have been this and right portion would have been this. This is the point in the extreme left, this is the point in the extreme right. So this is the edge you are added. Will you add a 1 for this edge also? Nah, it is not even an edge. You can simply erase this. So the plus simply says, do you have a cycle or not? Which means x and y should not be same. So in the code, you will actually see that if x and y are not same, only then I will add a 1, which will actually say, okay, now I have a cycle. Now it's a valid cycle, which I have. Okay, great. So one thing is for sure that, okay, minimum distance will actually be a 3, considering it is a cycle right now. So now I will represent my this as a 2 plus. 2 plus will say, my minimum distance can be a 2 or a 3. 2 will be okay if my x and y are same. 3, it will be okay when my x and y are not same. Now it's as simple as that. If you want to contribute the answer for this specific 4 to all the other values, you can see, okay, answer will be, you can see minimum distance was a 3. So 1 will be a 3, 1 will be a 4, 1 will be a 5. So this 4 will contribute to the length of 3, 4 and 5. This 3 will contribute to a length of 4, 5 and 6. Same way. This 2 will contribute to a length of 5, 6 and 7, and this 1 will contribute to the length of 6, 7 and 8. Now you see it's nothing but a range which you are trying to actually say. So simply add a plus 1 in these range, plus 1 minus 1, and then do a prefix sum. So what I'll do, okay, I know the length they are trying to say is 3, 4 and 5. So simply add a, again, 2, 3, 4 and 5. Again, I'm saying this is the length. This is the length, not the index. So I'll simply add a plus 1 for the length and minus 1 for the length of 6. And the same way for this also, I'll do a plus 1 here and a minus 1. Sorry, and a minus 1 here, and thus simply do a prefix sum in the end. That's it. As simple as that. So you will see. Firstly, I will go on all the points. I'll go on all the points of my left, and then I would know simply that at what I need to do a increase and at what I need to do a decrease. When I will do that, I'll simply be iterating. I've simply iterated on all the left points, and then when all this entire thing is done, when you have gone all to all the left points, now you can simply go and try and look for the prefix sum, which you will do, because now you have the plus 1 added, right? It's simply nothing but adding a plus 1, doing a minus 1 on the correct points. Now simply do it, and that is done. Your all 6 cases are covered, and ultimately make sure that in the end, just have a quick thing which you will make sure is in the super end, please, when you are adding the answer for all of these 6 cases, please ultimately in the end multiply by 2 also. That's the only thing which I have to do. Again, a quick recap of the code. Firstly, I had these 6 cases in which this is the left line, this is the right line, this is only the circle, which is the cycle, this is the left line 2 cycle, this is the right line 2 cycle, and this is my 2 lines. And then ultimately it will multiply by 2 because of the house on house 2 and house to house 1 pairs. For all of these, I have a function written above that this was a specific function for only 2 lines. This was the specific function for only cycle. This was a function for only 1 line, either left or right. And this is the specific function for a line and a cycle, and all the functions separately having explained above. I hope that you guys have got it. Again, it's a very long video because this is a problem I have seen. This is the hardest problem I have seen in the last 8 months, just because of the cases which it involves. Again, they are explanation by burning points, but still it is entirely on this concept itself, and you will ultimately, if you are very smart, you can understand that. But I knew that you guys won't understand that burning points explanation because it is very complex. So yeah, that was the easiest, although the code might look big. That burning point code was actually a bit small, but yeah, that involves a way too much writing the code in a short space, but it is the best explanation I could bring on by entirely building this entire examples for everything whatsoever. So basically, I tried to have examples of every possible case, or even all the possible lengths. I tried to build the examples so that you actually understand how the things are being done. Cool, thanks for watching. Goodbye. Take care. Bye bye. Calls.